Hi, I just wanted to show one more thing about natural language processing with Python kinds of tools and a tool called Orange. And here it is. I have pre-made some flow diagram for natural language processing case where I want to study plenty of literature and try to use AI to help me to do a literature review. And this Orange is a nice Python-based tool where you have plenty of different kinds of modules for different kind of data analysis purposes. And one of these areas is called text mining. And Orange is an interactive tool that you can use without programming, and it's basically very simple. You just take what kind of modules you need and drag them here in the workspace, and then connect them together and you can analyze data. And here I have first this import documents module, which is reading a certain directory that I have called corpus dir, and it will import all the documents from there. And I can show you what I have in a corpus dir. I have here plenty of documents, and each of these documents describes one research article. For example, this I have here the title of the article, the publication year, and the abstract. And there are like 250 of these kind of articles. And this is now reading all the documents from that directory. And I can then I have placed here a pre-processing module that is doing this similar kind of pre-processing that we have already found out used in Python programming. It transforms all the data to lowercase. It can do some regular expression splitting into tokens, word tokens. It can remove stop words and normalize using lemmatizer. And it's all done within this module. And I can configure them here and add some more pre-processing options if I want. Then I have here the corpus. Yeah, I can look these documents using corpus viewers, but let's think about that a little bit later. I just show the main things here. For example, I can generate now the word cloud, which shows that which which words are the most typical in this corpus. Ice seems to be, and that's reasonable because I have used this, I have searched for ice detection methods. So ice and detection are some of the most common words here. Yes, so get some understanding what do I have in this corpus. And now I would like to do some assisted analysis based on this. First of all, I can easily create this concordance by just dragging the concordance component from this side panel into here. And when I have it here, I can study different issues like ice and snow or whatever, and I can see that how they are represented in these documents. These are all in one document, another, and so on. And if I add here a corpus viewer after this document, and then I select some article from concordance, I have it here, I can click it and see what's the content of that article, which is so much talking about snow. And indeed, it's something like based on satellite-based snow cover monitoring algorithms. So if I would be only interested in snow, I could select these articles and look them here and verify that these are what I'm really interested in. So something to help manual assessment of documents. Then I can do also so-called document embedding, that is using a standard database of words and topics. And this is actually mapping my documents into certain predefined topics. And what I have after this is, I can show it using data table, dragging this here, opening it, I can see that there are so-called dimensions. These are these topics, and there seems to be 300 dimensions, and now it has mapped each of these documents that I have into these dimensions. So how much this first document belongs to is about dimension 1, 2, 3, 4, 5, 6, 7, and so on. So this is now converted all these documents into 300 feature space, the space of 300 features. Then I can apply when they are now numerical, I can apply k-means algorithm like I have done here. And this has actually already proposed me that it would be that what is the good number of features to use. I can using so-called silhouette score, and it seems to be that the silhouette score reduces when I have more and more clusters in the data. So perhaps I'm not going to use too many, but let's try 4, for example. But then if I have now 300 dimensional space, it's a little bit difficult to visualize, so I have to convert them to 2-dimensional space, and Disney is very good on that. It can also capture some non-linearity. So I have now first transferred all these documents into 300-dimensional space, then make clustering, then I project them in 2-dimensional space, and let's see what we have. So all the documents, 250 documents, are now here. Color is now based on the cluster. So I selected 4 clusters. I could have selected 5 or 6 or more and see how it looks like. But let's not put too many on there. So now what happens is that each of the documents are here. I can actually, by putting the cursor on top of this document, I can see what document this is, what are the feature values of this 300 dimensional space, and also the color shows me that what is the cluster for this. So now it should be so that these documents here are a little bit like similar because they belong on the same cluster, and they are also located in the same area on this Disney space. And now this Disney space and k-means clustering are totally independent, so but it seems that they pretty much agree. So those articles which are close to each other in Disney space are also usually in the same cluster. There are some exceptions like these red documents here and so on. And if I now want to see what are these documents, I can again place a corpus viewer here after this Disney, and then I can from this Disney click these documents, and I can here see what is this document about. So this is CI drift tracking, and if I take, for example, select here a couple of articles, I could assume that these are pretty much similar. Grid faults, modeling CIs, microwave frequencies, yeah, maybe not exactly. And maybe one issue is here now that I have selected really narrow topic already, that is ice detection methods, and therefore maybe this general feature base is not working so well for these. If I would have just like a random discussions from the internet or something, then this could be quite useful way to cluster the data. But now when I already have a very narrow topic, maybe this is too general. So then instead of using this, I can also use like a custom-made topic mapping using this topic modeling module, and it has these two methods, latent semantic indexing a latent Dirichlet allocation, and actually 3 methods, also hierarchical Dirichlet process. And we already used this latent Dirichlet allocation LDA, so let's use that one. And it has now, I have said that try to find 10 different topics, and it has done that, and it is now here describing that this topic 1 is very much described by these words: bias, correction, previously, likely, front, some number, Markov spectroradiometer, and automated European. So let's study this a little bit further. So it has created these kind of 10 topics, and I can also now, let's remove this here, place this here, and let's see how this data looks like as raw. So now I have only 10 topics, but they are custom made for this specific data, so they may be more relevant. Let's see. So I have 10-dimensional space, and again the same issue. I need to visualize it, so I will create a Disney plot of it. And now you can see that there seems to be somewhat of clustering, and again there are a certain number of documents which are close to each other. I can select them and use another corpus viewer to look what these are. So this is talking about geohazards analysis using SAR interferometer. This is using capacitive to digital converter. This is something that is not related to my topic at all. Micro earthquakes, not related to this topic. Radio detector array, maybe that is not so much. Volcanic hazards, okay. Yeah, these are something like not so much related to my topic, but I was interested in. Let's try these other ones. Modeling insertion methane surface, interstellar. So this is a space research. Solid state circuits. Methanol ice. So this is like a chemistry based of issues, not yet what I'm actually looking for. Let's see, this one, it can be a good or a bad thing. Actually, it is a good thing if all these documents in one cluster are something I'm not interested in. Yeah, now we're talking about SAR data analysis. This is something I'm interested in. Sea ice, ridge detection. Yeah, tech demo. So this is GNSS reflectometer I'm interested in. Yeah, so this would be very interesting documents for me. But it's still not so easy to find out what is the actual topic of these articles. But anyway, this I would assume this is helpful for my purposes. And I could again run a clustering algorithm here and see if that would help. And anyway, I believe that already this helps me in finding what I'm looking for, and this concordance analysis is really interesting. And also I can, if these are not good, I can also do manual searching from these. So I can select certain words, a combination of words, and then see that how these different documents match, and search these documents using these kind of search tools. So there are plenty of options in Orange for doing this NLP, and this is especially useful if you don't know yet exactly what you are looking for, what kind of tools could be useful. So this is a fast way to interact with the data, try different algorithms. You can find a good list of algorithms already here. and so easy to try different methods. And then when you find something useful, then you can just make your own program for it. The disadvantage with Orange is that it's of course it does not support everything. It supports what you have here, and you can also add put add-ons, and this is actually already quite a considerable list of different areas where you can apply these methods, but it doesn't of course contain everything. So programming is more flexible than this, but it's already really good set of algorithms, and it's also taking much more memory than the actual Python program. So if you have very large data set, you may need to do it in a programming way. But anyway, this is also good to know, a good way to start working with NLP and try to learn these NLP topics and know what you want to do. And when you know, then you can make a program. Yes, thank you for listening.